Let's get started on solving systems of equations by graphing now. We are going to be doing a number of problems where they give you two equations and you're going to plot both of the equations on the Cartesian plane, and we are looking to see where they intersect each other, and that point or points of intersection is the solution to the equation, meaning that that point we get, or points in some cases, that we get can be used in both equations and are solutions to both equations. So that's what it means to solve it. All right, you're finding a solution that works for both equations. So let's look at these in full, complete disclaimer here. Graphing on this iPad that I'm doing these videos on is not easy, so it's not going to look like Khan Academy where they're nice and straight and everything. So I apologize, but the idea is to give you the spirit of what's going on here so that you can take this then and use it on your own. So let's take a look at these equations here. I'm gonna write them each down as we graph them. So we got y equals x plus 3. So for this one, I'm going to show you using slope-intercept form because I'm not giving you the easy way out and making everything with the table, because you gotta learn this. All right. So slope-intercept form is y equals mx plus b. All right. So m is always the coefficient that's in front of the x. In this case, there's not one listed, which means it must be 1. All right. And then the plus b is either a plus or a minus, and it'll be a number off to the right of where the x is. So the way I like to do these is let's find your y-intercept, which is 3, right? Put a point there, okay? And then my slope is 1. So if my slope is 1, that means it's 1 over 1. Because remember, whenever you get a whole number for a slope, just put it over 1. And it means it rises 1 and then goes over 1. And by going over, we always mean going over to the right. So it'll go up 1, all right? I'll use a different color that we can get rid of. It'll go up 1 and then over 1. And so I'm going to have another point over here. And granted, this isn't an ideal situation. I don't like having them that close together, but that's what we got. So I'm going to take this, I'm going to draw my line, and we're going to leave it right about there. No, I do not have 5 minutes Duolingo. I am doing something else right now. Let's do our next equation. We've got y equals negative 2x minus 3. So my y-intercept is this point right here, negative 3. So I got a point right over here. And then my slope is negative 2. So that means it's negative 2 over 1, which means it goes down 2 and over 1. So I'm going to, again, use orange to show this. So I'm going to go down 2 and over 1. And then right there is where I'm going to put my second point. And then I'm going to try to carefully do this. It's hard. And let's see. Yeah, that's not bad. All right, and then what you do once you have that is you say, okay, I have a situation where they meet. They meet about right here. And then generally speaking, I can look at this and say, well, this line I graphed just a hair high, a touch high. If it's a slope of 1, it should always be going through those grid points, and it's not. So more than likely, the solution to this problem is the point negative 2, 1, because that's the closest it's to. Right, and if you do this on Desmos or on Alex, you'll get an exact answer, which is nice. So the last thing you do with this, okay, and this is kind of important, is you're going to take this negative 2, 1, and we're going to put it into both equations to see if it works. So I'm going to take my first equation, which is y equals x plus 3, and I'm going to substitute 1 in for y. I'm going to substitute negative 2 in for x. And I'm going to see if that makes a true statement. So I get 1. 3 plus negative 2 is 1. So it works for this one. So for this one, it checks out. So let's try it for the next one. So the next equation, I would put y in, 1. And then we have negative 2. I'm using this equation right here now. Negative 2 times negative 2, and then minus 3. All right, so you get 1 is equal to, well, negative 2 times negative 2 is positive 4 minus 3, which is 1. And so it works out. So I know that my approximation was correct. I got the right answer. And that is how these problems work. I was planning on possibly doing another one with you. Basically, what I'm going to tell you, I'm just going to show you how to kind of get set up on this so that you could finish doing it on your own. You'll notice that on this one, they're not written necessarily in slope-intercept form. So what I would do is I would take each of them and write them in that form. So y minus 6 equals 2x. I would get to slope-intercept form by saying, well, y needs to be by itself. So I'm going to add 6 to both sides. And that gives you y equals 2x plus 6. So that's my first one that I'm going to plot. And my y-intercept is 6. And your slope is 2. So you go up 2 and over 1. And remember, this is going by 2s. So up 2 with 8 and over 1 would put you about right here in the middle. And then you get another one if you did it one more time over there. So you get a line kind of like that. All right. Then for this other one, you get y equals 2 times the quantity x plus 1 plus 4. Well, let's get rid of the parentheses and let's do a little combining of things. So I'm just multiplying this through, plus 4. And now let's add our constants together. So 2x plus 6. And now I have an equation I can work with. Well, my y-intercept is 6, so I can already see where it's going to intersect this other graph. And then my slope is 2 on this one. Well, I have kind of an interesting situation here, don't I? I have a situation where I pretty much have the same graph because it uses the same points. And we'll talk about what that means in a minute. All right, but that's for a later video. So I just want to kind of show you how to graph these, what these look like, and then what do you do with them. So that's how I would suggest approaching this, and good luck with these. And continue to watch the videos because we'll cover why this happened, and I'll explain to you what